All right. Okay. So this Jamboard. Okay, we're gonna talk about. Oh, not that one. I was trying something and it turns out. So we're gonna do something called. We're gonna prove two different ways, but we're gonna show that there are certain ways that are stupid. I mean, not stupid, but waste of time, while some are not. So I know Jamboard is gonna be destroyed on October 1st, right? So gotta love it while you can, and I hate that kind of brush. I claim we have a claim that says that a equal x and b equal y over here. And then I wrote that the a squared divided by 15 plus ab divided by 15 plus b squared divided by 15 equals zeros. As you know, that 15 really doesn't matter. So it's actually a squared plus ab plus b squared. I noticed that later on, so I first put that in there, but then realized later on, yeah, right, this question is kind of stupid. I made this question, fully admit it's a little bit stupid. Now, now, um, oh, this is x. Sorry, this is x. So b equal x. Now, with them being both equal x, you could literally say that this is x squared plus x squared. So x must be 0, and there's no other answers. Other than this. But if you want to be stupid about this, here's what you do: ab plus b squared. It still works. I I mean, it's not stupid per se. It's just that not the preferred method, but it is interesting to do it this way. I would never recommend my enemies doing this method at all, or friends doing this method at all, because you're gonna be stupefied. I think so. I actually used the A first, so it's actually um, I think it's this way. Who knows? This actually might work for a different method, different equation of that. But what I did was b equal x, which I should have wrote down in there, but who cares? I did this, and I said ax plus x squared equal negative a. Okay, and then what else did I do? I did x squared plus ax plus I think a divided by 4, because it has to be that it should be squared, which equals, because if I plus a squared divided by 4 here and plus a divided by 4 here, I get negative 3a divided by 4 square. So this is a perfect square, so that would give me, and a perfect square means well, if you do a polynomial expansion of this, you get that, and then that's a perfect square. A lot of people. Uh, so I need to get a new Jamboard, because what I mean by that is that because Jamboard is going to be destroyed, I need a new site that act like Jamboard. I don't know if Google has a site like that. Anyways, we have this and this, so now we could do x plus 9 divided by 2 equal plus or minus square root of negative 3a squared divided by 4. You will prove that plus or minus doesn't matter, but for now we can't say that. This is a also. Minus a divided by 2, so we get rid of that. So we get x equal square root of minus 3a divided by 4, as clearly seen over here, minus a divided by 2. Now, I do want to see actually if there's a new Jamboard, but we'll figure that out. Oh, this is plus or minus. So next, what we do actually kind of matters, I guess. Well, actually, it does matter, and I'm wrong about this. Ooh, I just realized that I made a huge mistake. No, 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 no. I'm pretty sure I tested this out. The minus version of this gives me the same result as this. You could test it out yourself, but I tried it. I believe it turned out that way. We'll try it. We'll try again later. But with that said, what I did after was say that x squared plus xb plus b squared and plug an x to here. So if we do that, and this equals, because this is such a complex function, I'll have to put square there. Let's just simplify a little bit. And this is plus or minus now. This is carried over now, and this minus would stay inside of it, but that equals I equals square root of -1. Now with I in here, oh, this is wrong. It's A over here. We have square root of 3 here, minus A squared divided by 2. Wait, did I get that wrong here? No. No, I'm pretty sure I did it right. Oh, I'm wrong. Okay. So this minus stays 2. I knew something was wrong. That didn't make any sense. Anyway, we got this answer. Now what we do next is this is plugged into here. Now plus or minus a divided by 2 I square root of 3 minus a divided by 2. So this is plus or minus. So we can get multiple answers here. My A's looks like 9s, I know. Now, since this is plus or minus, we actually need to do 2 different operation because otherwise there's probably a theorem for this, but we don't know that theorem, so we're just gonna have to do it manually. Why am I so slow? I can just memorize it. Yeah, why am I so slow? And if I'm wrong, it's just plus or minus wrong, so I can double check later. And then we just have to do 9 divided by 2 with a negative version here. And all minus here. So now, why won't it matter? Well, this negative will negative. That just cancels out as a plus later on. And then that equals the same thing. And then a that. So that equals plus over here. But this equals a plus over here too. So somehow they all cancel out to the same amount, I remember. I don't know why, but I remember it. So let's just say you can try it at home. So in the end, I don't want to do that again. So in the end, that equals negative a squared divided by 2 plus a squared I square root of 3. Now that's the final answer we have given here. Now, what we're supposed to do is plug it back into this place, but we only did this part, right? So, which is a hard part, but that equals this. That is this part. Now we just have to plus that by a divided by 2 I square root of 3 minus a divided by 2 parentheses b minus b squared, which is constantly seen. So why is that important? Let me just get me why would I care? Well, we'll soon see why. It's not really that important thinking about it. It's just a fun thing you can realize here if you know math really well. Now, one thing to note is that if you have imaginary and real, real cannot cancel out imaginary, and imaginary cannot cancel out real unless you do squares or something special with it. So what we know over here is that these two parentheses I squared root of 3, and then this, which is minus a divided by 2 minus ab divided by 2 plus b squared. Since this is the real portion, this cannot cancel the I because that's an imaginary space. We denote imaginary space as I1, I2, I3, like making 2D. The reason why it's different than regular Cartesian plate is that this is imaginary looping, which is going to is some people I consider it another dimension, but it's actually, if you really think about it, it's having one input by having two outputs. So if there's a space that has an I, that's actually two inputs, not just one output. No, one input but two outputs. Sorry. So what it could be is like, for example, I inputted 3 plus 4i as a vector, which gives me, actually, this is a bad example because this would be hard to do with, you know what, whatever. EI and then angle. So this angle, what is it? What's this phasor? Arc tan of, see, 4 divided by 3, 4 divided by 3, arc tan, um, arc tan of, I'm not going to worry about it. In degrees, let me get it in degrees. I don't want it in, well, be awful. Let me, oh, arc tan. What was that anyways? Oh yeah, that thing. Arc tan radians actually, because if I remember correctly, 0.12, so 0.1, what was it again? 31. So this answer over here will be the input, the z input. This will be one input, and then what you get out would be two inputs, a real and imaginary. So it could be like 4 plus 5i. You could say that 5 is one output and 4 is the real input. So it's like a different dimension, but it's not, because I is equal to square root of -1. So technically speaking, it has something, and it is a value. It is a tangible value that you can put into a system. Now, what does that also mean? That this is a bad example, actually. Yeah, you could also say that you give yourself an imaginary input like 4i and get yourself out 3 plus 4i by a function of z. So over here we have two output and then we have one input. So we can also say that we have two and then the real world, and we can have complex output, and then we have two distinct outputs that will be individual, which means that you can make something like a 2 represent 5 and 4, and then this 4 denotes like 45 degrees in this building, and this 5 means 65 degrees in this building, and then for some reason they need to be in that perfect equidistance to make some kind of experiment across each other, thermal experiment where they clash each other. That could work, I think. Well, that's just generally the idea that I was taught. So yeah, that's the real reason. But I'm getting sidetracked on tangent. But this basically states that it cannot cancel with real. So this must be 0, because otherwise, what else can it be? So a must equal 0, but then a equals x. So that must mean x equals b, then b must equal 0. So this is all 0. And then if a equals 0, then this whole thing must be 0, and the whole thing must be 0. So a and b equals 0. Therefore, this proof is sound. It's just stupid. It's just fucking dumb because you can always do this. So what the important lesson over here is that the idea of there's methods that work that are interesting and fun to do, but practically it has no use. And mathematicians have a lot of useless things for engineers. Um, yes, yes, they have a lot of theorems for no hill of a reason. But this problem was made by me for just jokes. But yeah, yeah, this was stupid. I'll fully admit this was stupid. This was created by accident also. The actual question was going to be super simple. A squared plus 2ab plus b squared. That's kind of obvious to make it. As you can see, I'm redesigning my whole document where I'm deleting chunks and remaking it. I think this is better, uh, having it like this. Took a while to do that. And also I need to redo this thing because I don't like the answer key situation. I think for this document, the answer will be given. The point of this is learning, not testing your skills. So I'm gonna do that instead. So that's the plan.